Okay, so is the voice visible? Sorry, is the voice audible?
Yes, sir.
Okay, okay. So we have seen till this sum, right? Yesterday.
Yes, sir.
Okay. So we'll proceed to the next one. So yes, and this is another question from your book. Okay. So is the screen clear for you to read the question?
Yes, sir.
Okay. So a woman starts, okay, from her home at 9 a.m. Okay, walks with a speed of 5 km per hour. Okay, on a straight road up to her office, that is 2.5 km away, stays at the office up to 5 p.m. and returns home by an auto with a speed of 25 km per hour. Choose the suitable scales and plot the xt graph, that is position time graph of her motion. So could you understand this question? So a woman starts from a home. Let's say this is her home. Okay. So let's say this is her home. Okay. So she starts from her home at 9 a.m. Okay. And okay. So she walks the speed of, sorry, she walks the speed of 5 km per hour. Okay. On a straight road. Okay. To her office. Let's say it is the office here. Okay. And it is 2.5 km away. Okay. So just a moment. Yeah, Vishwa, welcome to the class. And so from her home, okay, she goes to the office. Okay, she starts at 9 a.m. So she goes at a speed of 5 km per hour. Okay, and she goes to the office that is 2.5 km away from her home. Okay, so she stays at the office till 5 p.m. Okay, and returns home from the office. She returns home. Okay, by an auto with the speed of 25 km per hour. Okay, so we have to choose the suitable scales and plot the xt graph, that is position time graph. Okay, so could you understand the question first, what they are implying?
Yes, sir.
Okay, so any idea, so how can we solve this problem, any idea? Anyone? So any idea, can you try? Okay, I'll tell you. Okay, so okay, so I can plot this graph like this. So that is, so let it stay here. Okay. Okay. Welcome to class, Shruti.
Yes.
So yes, yeah, welcome. And we are, in the next question. Okay. So that is last class we have seen from this till this question. So we are going to the next question. Okay.
Yes, sir.
Okay. I'll give you a minute. I'll give you a minute to understand this question first. Okay.
Yes, sir.
You can read for yourself, and if you say it's okay, then we can proceed.
Yes, sir.
Okay. So you're clear with that?
Yes, sir.
Okay. So we can take the scale as So first we'll draw a xt graph, that is, this is position time graph, no? So this x-axis represents the time, y-axis represents the position, that is x and t. Okay, So what we are saying, the woman starts from her home at 9 a.m. So I'm going to take this origin point now, that is O. Okay. So this origin point O has the woman's home. Okay. And she starts from her home at 9 a.m. Okay. She starts from her home at 9 a.m. So I'm going to, specify this time. Okay. The time is in, it's not here in seconds. I'm going to specify it in hour. Okay. So here at this origin part, I'm going to say it as 9 a.m. Okay. And this is going to be 10 a.m. and this is going to be 11 and this is going to 12. Okay. So 1, 2, 3, 4 and 5 p.m. right? And finally 6 p.m. Okay. Clear? What am I doing here?
Yes, sir.
Okay. So they are saying this office at 2.5 kilometer away. Okay. So I'm going to choose that y-axis each division as just 0.5 kilometer. Okay. So here from here to here it is going to be 0.5 meter and this is going to be 1.0, sorry, kilometer, sorry, it's not meter, it is kilometer. And it's going to be 1.5 kilometer. Okay, in terms of 0.5 kilometers I'm taking. Okay, so it's going to be 2 kilometer and it's going to be 2.5 kilometer. Okay, so in the time axis I took each division in the time axis as each division represents, okay, 1 hour of time. Okay, 1 hour, that is 9 a.m., 10 a.m., 11 a.m., 12 a.m., 1 p.m., sorry, 12 p.m., 1 p.m., 2 p.m., 3 p.m., 4 p.m., 5 p.m., 6 p.m. Okay, and each division in the y-axis, that is the position axis, I have taken in terms of 0.5 kilometer per hour. Sorry, 0.5 kilometer distance. Okay, so here the position x is in kilometers. Okay, the only difference, normally it will be in the meters. Now I have taken it as kilometer. Time will be in seconds. Now I have taken it as hours. Okay, you clear with this?
Yes, sir.
Okay. So what they have given the question, we have plotted the graph. So uh, you know she walks on a straight road up to her office. Okay, that is 2.5 kilometer per hour. So the woman at 9 a.m. she walks at a speed of 5 kilometer per hour straight up to her office, that is 2.5 kilometer away. So she travels here to here, that is 2.5 kilometer. Okay, at 9 a.m. she travels to 2.5 kilometer. Okay, distance. So earlier we have seen here, no? So from she starts from 9 a.m. So she travels 2.5 kilometer per hour, and we don't know what is the time she reaches here, right? So that is not given the question, so we have to find it out. Okay, so she started at 9 a.m. She traveled 2.5 kilometer to reach the office. She reached the office, but at what time? That is not given, so we have to calculate it. Okay, so how to calculate it? As you all know, speed is equal to distance by time, right? Are you with me?
Yes, sir.
Okay, so what is the speed given in the question? 5 kilometer per hour. Okay, so speed is equal to, I write it here, that is 5 kilometer per hour. What is the distance she travels? 2.5 kilometer. So time. So I'm going to take this time here and take this speed here. So time is equal to 2.5 kilometer divided by 5 kilometer per hour. Right? Okay. So we can, yes, we can simplify, that is 1 times by 2. So time is equal to 1 by 2 hour. That is half hour, right? Okay. So it becomes 30 minutes. So the woman takes to reach the office. She takes 30 minutes to reach the office. She starts at 9 a.m., travels at the speed of 5 km per hour. So she travels 2.5 kilometers. So when she reaches office, it takes her 30 minutes to travel 2.5 kilometer. So that is the thing. So she starts at 9 a.m. So what is the time she'll reach here, the office? It has taken her 30 minutes. So what will be the time?
9:30, sir.
Very good. So at 9:30 she reaches the office. So we have to plot that. So I'm saying this is going to be 9:30. Okay, 9:30 is here. Okay, so I'm going to erase all this. Okay, so I'm going to write it here. That is 0.5, 1, 1.5, 2, 2.5. So this is 9:30, right? So I'm going to mark this. Okay, so from home to the office she reaches here. Forgive my drawing. Okay, is it clear? Okay,
Yes, sir.
right. So what is the second thing they have given the question? She stays at the office up to 5 p.m. So till 5 p.m. what happens? Yesterday I think Auxilia answered. So Auxilia, what happens till 5 p.m.? Whether she is in motion or she is at rest.
Rest, sir.
Okay. So is it fine by everybody? You all agree with that? Jayashri, Shruti, Saumya, you all agree with what she said? Mrinalini, yes. Thank you, thank you. So she's at rest, no? She reaches the office here. So till 5 p.m. Okay, she's at rest. So I'm going to draw a straight line. Okay, till 5 p.m. Okay. Now what happens? So she returns home by an auto with the speed of 25 kilometer per hour. She returns home by an auto. So she returns home. Okay, here from here to the home by an auto at 25 kilometer per hour. We know that she has started at 5 p.m. right? We know that she started from the office by 5 p.m. because till 5 p.m. she was at the office. So at 5 p.m. she has started to return home. So she hired an auto, okay, which you know, which traveled at a speed of 25 kilometer per hour. So what will be the time she reaches here? So the same way, speed is equal to what? Distance divided by time. What is distance? The same, 2.5 kilometer per hour. Speed is 25 kilometer per hour. Okay, time you don't know, so interchange it. So time is equal to 2.5 kilometer by 25 kilometer per hour. So it becomes 1 times and 10. So time is equal to 1 by 10 hour. So you can change it into minutes, no? That is 1 by 10 into 60, right? So it takes 6 minutes. So it takes 6 minutes. So for the woman started from her office at 5 p.m. So it took her 6 minutes, okay, to reach here. So at what time she would have reached there to her home? Are you guys all there or
Yes, sir.
yeah? So at what time she could have reached? Whether
5,
Nitish is
6.
there? Yeah,
5, 6, sir.
yeah. 5. That is 5 6, right? 5 p.m. 6 minutes. Okay.
Yes, sir.
So I'll take it here. This is 5 p.m. 6 minutes. Okay. So I'm going to plot it here. Sorry. So this is how your graph should be. Okay. So you guys clear with this? Nitish, Saumya, Shruti, Vishwa, Jayashri, Murnalini, Disha. Are you guys clear with this? Yeah. Okay. Okay. Thank you, Nitish. Thank you for your response. What about? Yeah. Thank you, Murnalini. What about Saumya, Shruti, Jayashri? Disha is there. So shall we move on to the next one? Okay. Yes.
Yes, sir.
Okay.
Yes, sir.
Okay. So yeah, another sum is here. NCRT example that is given in your book also. That is a drunkard walking in a narrow lane takes 5 steps forward and 3 steps backward, followed again by 5 steps forward and 3 steps backward, and so on. So each step is 1 meter long and requires 1 second. Plot the XT graph of this motion, determine graphically and otherwise how long the drunkard takes to fall in a pit 30 meters away from the start. So could you understand this question by reading? So are you able to understand this question by reading? I'll walk you through, but still I want to know whether you know it is understandable or not.
Yes, sir.
Okay. So a drunkard walking in a narrow lane takes 5 steps forward and 3 steps backward. So he takes 5 steps forward. Okay. Let's say this is one, two, three, four, and five. So he takes, this is a drunkard. Okay. So he takes 5 steps forward and 3 steps backward. Okay. So 5 steps. Okay. Each step is, they have given each step is 1 meter long. Each step is 1 meter long. So what happens after going through the first 5 steps? Okay, then he comes back 3 steps backward. So that is from here he comes to here. That is one step, and here second step, and here. So he takes 5 steps forward and 3 steps backwards. This is one step, and one step. So 3 steps backward. So each step is 1 meter long and requires 1 second. So what happens when he takes 1 to 5 that is 1 to 5 to take 5 steps? What is the time taken?
5 seconds, sir.
5 seconds. Very good. And after reaching this 5 step, okay, fifth step, then he goes on. He comes backward. No, so that is 3 steps backward. One, two, and three. Let's say here it is two. This is three, and this is four. So he takes 3 steps backward. So what is the time taken for that? 3 steps?
3 seconds.
3 seconds. Very good. So what is the position? That is here, the first is 5 seconds that he takes in the forward direction, and second in the 3 seconds that is he takes in the backward direction. So totally this one cycle of motion requires 8 seconds. 5 plus 3. Okay. So where will be at 8 seconds, what is the how many steps you have taken? Like he's here, first 5 seconds, no? He goes, let's say this is okay. So here, so he takes one step forward, okay, and he takes another step forward, and another step forward, and another step forward, and another step forward. This is fifth step, okay. So this is one step, second step, third step, fourth step, fifth step, okay. So it takes 5 seconds, and he has crossed 5 steps. Okay, that is he has moved 5 steps forward. So, and from here he goes to the backward direction. That is one step, second step, third step. So it is four. This is three, and this is two. So it takes 3 seconds, and he has taken 3 steps backward. So he is at the where at the distance 2
2 meters.
meter. Very good. So for 8 seconds, what is the distance he travels? 2 meter. Okay. So you understand this, everybody?
Yes, sir.
Okay. What about others? Do you want me to repeat it again? No problem. Okay. So you understand this concept? What they are saying? It takes 37 seconds to fall in the pit. Very good. That's the right answer. So everybody's okay with this? You understand? Is it, you guys are understood this problem? Okay, thank you, Manalini. So it takes 8 seconds, okay, to travel 2 meters. That is, 2 meters. Okay. So first 5 steps he goes forward, and and you know and from the 5 steps he takes 3 steps backward. So 1, 2, and 3. So he at the position 2 meter, and followingly, and again he will take 5 steps forward. That is 3, 1. That is here 1, 2, 3, 4. That is okay 4, and 5. Okay, that is 3, 4, 5, 6, 7. So at the end of another 5 steps, another cycle, okay, he'll be here at the 7th step. He would have crossed 7 meters. Okay, and what will happen? He'll come back, no, 3 steps backward. 1, 2, and 3. So here 8 seconds gone. So here also 8 seconds gone. So he'll be at this position, that is 4th position. Okay, he'll be at 4th position. Okay, so subsequently, so he is at 4 meters or 4th step. Okay, I'll write 4 meters. Okay, so in the 3rd cycle, what will happen? He'll go 1 step forward, another step forward, and another step forward, and another step forward, another step forward. So it's going to be 5, 6, 7, 8, and 9. Okay, so 1, 2, 3, 4, 5, right? And you will take 3 steps backward. That is from here to here. That is 1 step, and here to here, 2nd step, and here to here, 3rd step. So he'll be at here. He'll be at 6 meters. So here another 8 seconds gone. Okay. So already he traveled 2 meters at first 8 seconds, and another, he was at the position 4 meters at another 8 seconds. Now he is at 6 meters, position 6 meter at another 8 seconds. Okay, so now he'll be at the 6th meter. Okay, from now he'll take 5 steps forward. That is 7, 8, 9, 10, then what, 11. So you have to take 5 steps forward and 3 steps backward. That is 1, 2, and 3. So he'll be here, this position. He'll be at 8 meters at the end of this 8 seconds. Okay, so again he'll start from 8. Okay, he'll start another 5 steps. That is 9. That is 1 step. 10, 2nd step. 3rd step. 11, then 4th step, and 13th step is where is the pit is there. So he'll fall down the pit, right? So from 8, from 8th position, that is 8 meters, he'll take 5 steps forward. That is 9, 10, 11, 12, and 13 meter there is a pit. Okay, so he'll fall off on that pit. Okay, so what it takes here, it takes only 5 seconds only, not the other 3 seconds, because the man has fallen in the pit. He will not come back. Okay, so what is the total time taken? 2 meter, that is here he is at 8 meter at the end of another 8 seconds, and he will reach the 13th meter at the end of 5 seconds. So what is the total time taken? That is the time taken for the drunkard to fall in the pit at 13 meter is 8 plus 8, 16, 24, 32, 37 seconds. Very good. So you can plot this graph. Okay, you can plot this graph, and what you can do is the xt graph, to plot this graph in the time, you can have it as in terms of 5, 3. So since the drunkard takes 5 steps forward and 3 steps backward, that is 5 seconds and 3 seconds now. So you can take in terms of 5 to 3 seconds. Okay, so like this. So it's going to be origin, and this is time in seconds, and this is x in meters. Okay, so the distance you can take like this, that is, you can have it as 1, these are meters only, 1 2 3 4 5 6 up to 13 you can have. Okay, here you can have as in terms of 5 comma 3, that is 0 to 5 seconds, 5 plus 3 is 8 seconds. Okay, and 8 plus 5 is 13 seconds, and 13 plus 3 is 16 seconds. So likewise. Okay, and 16 plus 5 is what, 21 seconds, and 24, like that. Okay, so with this you can plot the graph. Okay, I can tell you the idea that it will come like this, you know so first 5 steps, no, so that is here, and it comes at the 8th second, it comes here. So likewise, so again it will go like this. So this is how it will go. Okay, you can, so you can draw this graph by yourself. Okay, then you can tell me if you want, you can try right now. You can say whether it comes like this or not. Are you guys clear with this?
Yes, sir.
Okay, you want me to uh, you know um you want me to draw this graph for you, the entire graph, or you can, I have given you the idea, you can also try, but you want me to draw this graph for you? Okay, so we'll proceed to the next one. Okay,
Yes, sir.
right. Okay, so we'll proceed to the next one. So the another one we are going to see is average velocity. Okay, average velocity. So that is, so when an object is in motion, so what we say when an object is in motion, what we will say, that it changes its position with respect to time, or with time, right? When object is in motion, we'll say that it changes its position with respect to time. Okay, the average velocity, this quantity tells us, okay, how fast is the position changing with time over an interval. For example, we can say that, you know an object is like this. Okay, at 0 seconds, let's say it has come here. Okay, at 20 seconds. Okay, so we know that from this diagram we can say that the object has changed its position from here to here, that the object was in motion between the time interval, the object was at motion, okay, between the time interval 0 to 20 seconds. Okay, but we don't know how fast it has been changing its position. For example, the object would have, let's say this is 1 2 3, something like that. So the object would have, from here to here, it has changed this. It could have came here and here and here, or you know it could have came here, here and here. You understand that? That is how fast it has changed its position. Okay, so the object could be like, it have changed its position like this to come here. It could have changed its position like this, or the object could have changed its position like here to here, or here to here. It's only 3 points, and here there are various points. Okay, the points where it has changed its position. Okay, to measure this, we define this quantity called average velocity. So it tells us how fast the object has been changing its position between the time interval. Okay, so the average velocity is, denoted, is defined as the change in position or displacement, change in position or displacement, okay, divided by time interval. Change in position or displacement divided by time interval, that is del t. Change in position or displacement, that is del x. So the average quantity, average velocity can be denoted like this. Okay, this the bar over the velocity tells us that it is an average quantity. So that is del x by del t. So this is average velocity. Okay. And some characteristic of this average velocity is same. As you know, it depends upon the displacement, right? So it is a vector quantity. Okay. So it is a vector quantity. And what else? Since it depends upon the displacement, what characters could it have? Anyone? So it depends on the value of displacement. Okay. So average velocity is also a vector quantity. Then what else? What about Saumya Lakshmi, Shruti, Disha?
It can
So
have plus minus zero.
yes, it can have positive, negative, and even zero values. Okay. So this is what about average velocity. Okay, average velocity is defined as the change in position divided by the time interval. Okay, so it is a vector quantity. It can have positive, negative, and zero values. Okay, so another quantity is average speed. Okay, here it involves only the displacement of the object. Okay, in motion. In average speed, it involves the distance of the object. Okay, the distance traveled by the object. That is, I am writing is just v is equal to total average speed is equal to total distance traveled, okay, divided by total time taken. Okay, total distance traveled divided by total time taken. And here the average velocity unit is meter per second or meter per second inverse. And here average speed also the same, unit is meter per second or meter second inverse. Okay, so average speed is what? Since it depends upon the distance or the path length, it is a scalar quantity. It is a scalar quantity. Okay, so then what are the character? That is, since it depends on the path length, it is a scalar quantity. Then we can always
Plus
say
alone.
it is
Positive, sir.
always positive. Very good. And another thing we'll say that average speed, we can say that average speed, okay, is equal, okay, is equal to the magnitude of average velocity. Okay, average speed is equal to the magnitude of average velocity. You understand this? But since it is a condition, for that we have a condition that the motion should be along a straight line. That is one condition. Okay, straight line, and it should be along a same direction. It should be along a same direction. Okay, so what we can say, I'll give you something. When can we say distance is equal to displacement? When the motion is along a straight line, right?
Yes, sir.
And yeah, when it travels along the positive direction, right?
Yes, sir.
So okay, so sorry, distance is equal to displacement. Okay, so when distance is equal to displacement, we can write it as average speed, that is as, is equal to average velocity, because average speed depends upon the distance and average velocity depends upon the displacement. So when distance is equal to displacement, okay, then average speed is equal to average velocity. Okay, so here another tricky one is, for this, to attain this, what we have to do, you know the condition, that is the motion should be along a straight line, that is there, and it should be in the positive direction. Okay, and what I have said, that average speed as is equal to the magnitude of, okay, magnitude of average velocity. Okay, so I'll give an example. Let's say 0 to p. Okay, 0 to p. So it has traveled from 0 to p. 0 is nothing but, we have seen earlier, no, 360 meters, right? So the car has traveled from 0 to, that is o to p. Okay, op. So what is the distance? What is the path length? Come on, quick, ma. So what is the path length from 0 to p? It is,
360 meters, sir.
okay. Then what will be the displacement? That is also 360 meter.
That is, yes, sir.
Yes, because it is in the positive direction. So I'll give you another example. Okay, that is okay. So this is a valid point now. For this operation, average speed is equal to the magnitude of average velocity. We can say like that or not?
Yes, sir.
Yeah, we can very well say like that, right? Suppose the car travels from here to here. This is the final point. PO, the operation is PO. So what will be the path length? Come on, quick. What will be the path length when the car is traveling from P to O?
360, sir.
Very good. So path length is 360 meters. What will be the displacement for PO? Come on.
Minus
Minus
360.
360, sir.
Very good. Minus 360. So here we are saying that average speed is equal to the magnitude of average velocity. And is this statement is correct for this PO operation?
Yes, sir.
Yes, no? Because this is, okay. So if this is, it depends, average speed will be, dependent on path length. Okay, so average velocity will dependent on del x. Del x is nothing but minus 360, and path length is just 360. Okay, so we can say that average speed is equal to the magnitude, only this is equal to this. You understand? This represents the direction. Okay, so this average speed, that is equal to the magnitude of average velocity. You understand my point?
Yes, sir.
Okay. So when it is in the positive direction, we can very well write as average speed is equal to average velocity. Okay. If it is in the negative direction, okay, if it is in the negative direction, this statement will hold up. That is, average speed is equal to the magnitude of average velocity. Only the magnitude, not the direction. Right? You understand this?
Yes, sir.
Yeah, based on this, there is another problem you have. It's a NCRT problem. So as you can, you can read this. No, a man walks on a straight road from his home to a market 2.5 kilometer away with this, that is away, with a speed of 5 kilometer per hour. Finding the market closed, he instantly turns and walks back home with a speed of 7.5 kilometer per hour. What is the magnitude of average velocity and average speed of the man over the time interval 0 to 30 minutes, 0 to 50 minutes, and 0 to 40 minutes? Here, see, note, you will appreciate from this exercise why it is better to define average speed as total path length divided by time and not as magnitude of average velocity. You would not like to tell the tired man on his return home that his average speed was 0. So can you make anything out of this question, or at least from this note they have given? So average speed is defined as total path length divided by total time taken. Okay. So what we have seen, average speed is equal to the magnitude of average velocity, right? So they are saying it is better not to define that, because you will be telling the tired man on his return home that his average speed was 0. So we'll see one by one. Okay. So a man walks on a straight road from his home to a market 2.5 kilometer away with a speed of 5 kilometer per hour. Okay. So what will be the 0 to 30 minutes? First we'll just do that. So okay. So man walks 2.5 kilometer to his market from his home. Let's say this is home H to market, that is 2.5 kilometer away, and he travels a speed of 5 kilometer per hour. So we can find the time, that is speed is equal to distance by time. Time is equal to what? Distance by speed. So that is distance is 2.5 kilometer per hour. Speed is 5 kilometer per hour. That is 2.5 kilometer. Speed is 5 kilometer per hour. That is, we can simplify as 1 by 2. So time is equal to half hour. That is 30 minutes. So the man starts from here, though it is 0 seconds, we can say. So he reaches the market in 30 minutes. So they are asking what is the magnitude of average velocity and average speed of the man over the time interval 0 to 30 minutes. Okay, 0 to 30 minutes. So you can very well, right? What is the average speed? First, first, what is the average velocity? What is the average velocity? So this is 0 and this is you know 2.5 kilometer. Okay, and it took 30 minutes. Okay, so he started from 0 meters 0 seconds, and he ended up here at 30 minutes. Okay, so what is the average velocity? What is the average velocity formula? That is del x by del t, right?
Yes,
Del
sir.
x by del t. So here you know that what is del x? This is the final position 2.5 fp. This is the initial position. So what is that? 2.5
G.
minus 0, right? What is del t? Del t is 0 to 30 minutes. I'm going to write it as half hour, right? So what happens? This 2 goes in the denominator, sorry, numerator, and 2.5 into 2 is 5. 5.0 meter per second is the average velocity. Are you with me all? You all with me?
Yes, sir.
Yeah. So average velocity is 5 meter per second. So what will be the average speed? You can very well tell that it is also 5 meter per second, right? Without calculating. Hello. So without calculating, you can tell that the average speed is also what? Average speed is also what? 5 meter per second. Why? Because the motion is along a straight line and in the positive direction. So distance will be equal to displacement. Hence, average speed will be equal to average velocity. Right? So for this time interval, we have done. So what is 0 to 50 minutes? The second time interval they're asking is 0 to 50 minutes. So what will be the average speed and average velocity for that? So I'll just erase all this. Okay. So what will be the 0 to 50 minutes? Let's find out this one. So from the market to the home, he travels at the speed of 7.5 kilometer per hour. So we'll calculate the time. Okay. So that is he starts here by 0. This is 2.5 kilometer per hour. So speed is equal to distance by time, right? So time is equal to distance by speed, that is 7.5 divided by, sorry, 2.5 divided by distance is 2.5 divided by 7.5 kilometer per hour is equal to time. So what happens here? 1 by 3, right? 1 by 3. So in terms of minutes into 60. So it goes 20 times. So the time taken is 20 minutes. For from the market to the home, it takes what? 20 minutes. Here you have to see from the home to the market, it took 30 minutes. So he found that the market was closed, right? Okay. Then immediately he turned back to his home. It took 20 minutes. So the question here is what happened between 0 to 50 minutes. So now you can tell, right? So what will be the average velocity for this motion? Come on, you can quickly you can tell. So what will be the average velocity? It is 0, right? For this one, 0 to 50 minutes. It is 0 or not? Come on, students, are you there?
Yes, sir.
Yeah. So you're getting how we are getting average velocity as 0 for the time interval between 0 to 50 minutes. Kindly respond, please. So why average velocity is 0 here? Do you know the answer or shall I proceed or what? Or shall I? So you guys get how this average velocity becomes 0 for the time interval 0 to 50 minutes?
Yes, sir.
Okay, how? Because del x
So
becomes
its
0.
final position is same.
Yes, del x becomes 0, right? So average velocity is equal to del x by del t. So initial and final position are same. So del x becomes 0. So average velocity is 0. So what will be the corresponding average speed? What will be the average speed?
It is also 0, sir.
How come it is 0? You can tell me, no problem.
Sir, average speed is equal to the magnitude of average velocity, no, sir?
Yes. So yeah, very good. So what is the conditions for that? Your good name?
Sir?
Your good name, ma?
Axilia, sir.
Auxilia. You said average velocity, sorry, average speed is nothing but the magnitude of average velocity, right?
Yes, sir.
What are the conditions for that?
Sir, it should travel along the straight line,
Yeah,
sir.
that is there. Okay. Then the second condition?
Displacement should be equal to distance, sir.
No, that is okay. Uh, Displacement should be equal to distance. When that
Sir,
happens, when distance is equal to displacement, okay, what we can say as average speed is equal to average velocity. We can write like this. But what we are saying is here, where is that? Yeah, average speed is equal to the
sir,
magnitude.
it's 0.1.
Excuse me, ma.
Is it 0.1?
Yeah, I'll come back to that. I'm just your good name, ma, the one who answered right now.
Disha, sir.
Disha. So, are you with me? See, she said it is also 0 because you said average speed is nothing but the magnitude of average velocity. Okay. So, when average speed will be equal to average velocity, when distance is equal to displacement, that is, it should travel along a straight line in a positive direction, right?
Yes, sir.
Yes. Now, for this for this for this motion we cannot say average speed is equal to average velocity or distance is equal to displacement. We cannot say for this 0 to 50 minutes. You understand? We cannot say distance is equal to displacement for this 0 to 50 minutes. Why? Let's say here, what is the displacement for the 50 minutes, 0 to 50 minutes? What is the displacement? 0, right? Because initial position, final position are the same, right? So what is the path length? That is distance for this. It traveled 2.5 kilometer from here to here. From here to here, 2.5 kilometers. So what is the distance here? 5 kilometer, no?
Yes, sir.
Okay, so distance is not equal to displacement. So average speed will not be equal to average velocity. You get my point?
Yes, sir.
Okay. So when can we say that average speed is the magnitude of average velocity is? Please remember, as you know, that it should be on the straight line and in the same direction. Whether negative or positive, it doesn't matter. It should be in the same direction. Here, there is a change in direction. See, here it has come here. Okay. Now it has changed its direction backwards. In the negative direction, it has changed its direction. So there should be a no change in direction in the motion. You understand? So when there is a change
Yes.
in, yeah, when there is a change in direction, we cannot say that average speed is the magnitude of average velocity. Okay, those two are different things.
Yes, sir.
Okay, so we know that the total path length for 0 to 50 minutes is what? 5 kilometer, right? So 0 to 50 minutes, what? 5 kilometer, right? So what is we have to find the average speed, no? Home to market, that is 2.5. Market to home, that is also 2.5. The path length is 5 kilometer. So the average speed is equal to total path length, TP, total path length by total time taken, TT, that is average speed. So total path length is nothing but what? 5 kilometer, right? Yes. Total time taken is 50 minutes.
Yes, sir.
Yeah, 50 minutes. So how can we write 50 in hours? 50 into 1 by 60, right?
Yes, sir.
Yeah. So 5 by 6, right? 5 by 6. Okay. So 5 into 5 by 6. Sorry. 6 by 5. Okay. So average speed is, so average speed is what?
6 meter per
6,
second.
Yeah, 6 kilometers per hour.
Okay, sir.
6 kilometer per hour. Okay. So what will be the 0 to 40 minutes? Any idea? 0 to 40 minutes. 0 to 40-minute interval. What happens for the third one? That is 0 to 40-minute interval. Okay. So the time taken is 40 minutes. You very well know that 0 to 30, what happened? From home to market, 2.5 kilometer per hour. Okay. 0 to 30. Okay. So 0 to 30, it was here. Okay. At the end of 30 minutes, it was at this point. In the next 10 minutes, what happens? Here it takes 20 minutes now, from here to here. That also we have seen. From market to home, it takes 20 minutes. They're asking the time between the time interval 0 to 40. So 0 to 30 plus from 30 to 40. This is the motion. You understand? They're asking 0 to 30 and from 30 to 40. So for the return journey, only 10 minutes. You understand this? The concept, what they're asking for 0 to.
Yes, sir.
Very good. I think Disha has given the answer. Okay, very good. So yeah. So what will be the, so you know that the distance traveled, that is in, so it is a motion. Okay. So 30 minutes plus 10. So totally 40 minutes. You know what is the distance traveled from 0 to 30? That is 2.5 kilometer. What will be the distance from 30 to here? That is this 10 minutes. You can say time is
2.5
equal
by
to
2.
2 point. Yes.
2.5 by 2.
2.5 by 2. Very good. 2.5 by 2. So that is, so it becomes what? 1.25, right?
Yes, sir.
Yeah. So the return distance is what? 1.25. We can write it as like, we know what is the speed, that is 7.5. 7.5 is equal to, distance is unknown. Okay. So time is 10 minutes. Okay. So 10 by 60. So that's how you calculate. Then you know that the distance is 1.25. So the distance traveled between this 30 to 40 minutes is 1.25. Okay. So what will be the total displacement? So the body started here and ended here. This is the initial position. This is the final position. This is 1.25. So what will be the average velocity? What will be the del x? Del x is nothing but what is the final position? 1.25 minus 0, right? Divided by what is the time taken? 40 minutes, no? 40 minutes nothing but 2 by 3, right? 40 minutes. That is 40 divided by 60. Okay, that is 2 by 3. So 2 by 3, that is 1.25 divided by 2 by 3. So what happens here? So 1.25 into 3 by 2. So when you do that, you get, I think, 3.750. We can write a 3.575, okay, by 2. So the average speed is going to be 1.875 kilometer per hour. Okay, so this is going to be average velocity. So what is average speed? What is average speed? The average speed is total path length by total time taken. Okay, so average, the total path length is nothing but 0 to 30 minutes. It has traveled 2.5 kilometers.